Welcome to this podcast brought to you by the Vatican Observatory Foundation. I'm your host, Bob Trembley. I'm a volunteer NASA JPL Solar System Ambassador, the president of Michigan's Warren Astronomical Society, and an internet factotum for the Vatican Observatory Foundation. This podcast comes from a recording of one of our monthly full moon meetups with the Vatican Observatory staff and Sacred Space Astronomy subscribers. Sacred Space Astronomy is the Vatican Observatory's online community. We have several astronomers and scholars who write articles on our website about astronomy, space science, and faith in science. Every full moon, the Vatican Observatory Foundation hosts a Zoom meetup for our Sacred Space Astronomy subscribers. Typically, our guest will be a member of the Vatican Observatory staff or an affiliated researcher, and they'll tell us about the research they're doing and the journey that led them to the Vatican Observatory. Brother Guy Consolmagno, director of the Vatican Observatory and president of the Vatican Observatory Foundation, will typically talk with our guest, and our Sacred Space Astronomy subscribers can ask them questions. The audio for this podcast was taken from the full moon meetup on Monday, July 3rd, 2023. Our guest was Matthew Pinson SJ, who attended the Vatican Observatory Summer School last month in Rome. Brother Guy and Matthew were sitting next to each other in Rome when this was recorded, and we had viewers from all across the globe.
It's my delight to introduce to you Matthew Pinson.
It's great to be here.
Can you tell us a little bit about yourself?
Yes, I'm a Jesuit. I'm a member of the Australian province. So I've been a Jesuit about 7.5 years now. And before I joined the Jesuits, I did my PhD, not quite in astronomy, but fairly close in physics. In fact, I did that at MIT, which I imagine is pretty well known to some of you, and particularly as the former home of the man sitting on my left. And so that was actually the place where, through the community there, I really experienced a calling to live out my faith in a way that could also bring a bit of that scientific perspective, either directly in work or at the very least as part of a community where that intellectual way of looking at the world and engaging with questions of faith was valued. And so that's what brought me along the path that's taken me here.
So Australia is a big place.
Yes.
Where in Australia you're from?
So I grew up in a country town called Cowra. The way I tend to describe that is if you draw a line going west from Sydney and a line going north from Canberra, they'll intersect in Cowra. So it's a town of about 9,000 people, about 300 meters above sea level. It has a climate not so different from where we are in Albano at the moment, just a couple of degrees warmer and about 30% drier. So it's a distinctly dry place, but certainly less so than parts of Australia.
Well, I've got to ask, being an astronomer,
Yes.
What's your latitude?
Our latitude is about 32 degrees south.
So you are as far south of the equator as Tucson is north of the equator.
Yeah, that'd be about right.
What's the most northern constellations you can see?
Oh, I'm afraid I don't know my constellations.
Oh, no. Oh,
I look at the sky and I look for the Southern Cross. And as an Australian, that's how Australians who are not astronomers are brought up. It's bright, it's there in the sky, it's on our flag. It's part of us. And in a lot of Australia, including towns, you can see it. It's nice and bright.
Okay.
But I'm afraid that's sort of where my knowledge of stars begins and ends almost.
We're going to have to do something about this.
Yes, I think so, but I think I've come to the right place for that.
So what kind of upbringing did you have? What do you folks do? And were you raised on a farm or what?
I was raised on a few acres, about 10 acres or 5 hectares, and that was just for our use. It wasn't a commercial farm by any means, but we had sheep and goats, especially in the early years, chickens all the way through, an orchard, a lot of apples, as well as various other fruits. In fact, just the last few days, eating the apricots here is the first time since I would say about probably 1992, when I was 6. I remember we had a bumper crop of apricots. And since then, I haven't been able to find a good apricot. And I came here to Italy and the apricots are better. Apricots here are juicy in a way that I never imagined. So yes, I grew up loving the outdoors, the farm, but I was never as much of a farm person. I was more of a book person. I thought I'd left that all behind until during my second year as a novice, we did our 8-day retreat in Carcaw, which is just about 60 kilometers or 40 miles or so from Cowra. And I went out for a walk and it smelt like home. Now that smell is mostly sheep droppings, but still there's something about the smell that brings me back to those childhood days. And I thought, yes, this is part of me. And the big open skies, green for a fair bit of the year. It gets very dry in summer, but especially when you get a bit of elevation on the hills and you just look over gorgeous pastures, I think, yes, this is a part of me as well. So that was Dad's area of expertise was the farm and the children. I have 2 elder and 1 younger siblings, and he was a professional father for most of the last 35 years or so until a promotion to grandfather about 12 years ago. Whereas my mum was working at the high school that I went to, Cowra High School in town, teaching English. So certainly a family where education and nature and the environment were really valued, as well as the faith. Yeah.
So what got you into science?
I think I came really through maths. So I think that I'm quite a logical person. I like things that work in a logical way and understanding how an area of the universe works. And at high school, that particularly showed itself in maths. And that was the subject I sort of went a couple of years ahead in, because to find something that would actually be of interest to me. But when I was heading towards university, well, actually in 12th grade, I was part of the Australian team that went to the International Physics Olympiad in Seoul, not in Seoul, sorry, in Pohang in South Korea. And it was actually not so much the Olympiad, but meeting the tutors who ran the training school, because until then I really hadn't seen research scientists in action. I didn't know what that world was like. But I realized, well, these are people like me who have this logical way of thinking, but also an openness and a creativity to be asking questions and to be willing to not know the answer, but know that there is a way of getting, maybe not to a final answer, but to a way of understanding more. And I really thought I could be one of those people. Most of them were only a couple of years ahead of me in their academic trajectory. And so it was really in the car on the way home, Mum picked me up and talking to her and thinking, I think a research career might be of interest to me. And it was from that point that I followed it. And I found that at university, physics was a lot closer to what I'd experienced in maths in high school than mathematics was. So although I still enjoyed my maths courses, I enjoyed physics a lot more.
So where did you do your undergrad?
I did my undergrad at the Australian National University in Canberra in Australia.
And you were a physics major there?
That's right. Well, I'd call myself a physics major. I did this interesting degree program that had no majors. You had 6 required advanced courses, which could be sort of some extra coursework or some research. And other than that, no degree requirements other than a total number of courses. It was completely up to you to follow your particular interests. And so for me, that was super loading with every physics course I could find and a few maths courses in there too. But other people took it in all sorts of different directions, going for real depth or breadth or strange mixtures if that's what suited them.
And then from there, how did you even find out about MIT, much less think you were going to apply there?
So I think there were 2 parts to it, really. The first part was going on exchange to University of California, Berkeley, as a 3rd-year student. So that was not my first time overseas, but my first time overseas for an extended period of time. And I just loved it. There's something about American college life that has the social and so much going on. I thought I enjoyed that. The academic world opens up. There was sort of a limited amount you can do in one semester as an undergrad, but I could sort of get a glimpse of what was open there.
So your idea of a party school is UC Berkeley and then MIT.
That's right. Yeah.
Got it.
And that's what got me into American football. A lot of Australians are amazed that I became an American football fan. And then when I was getting about halfway through honours year, so our 4th year is a research-focused year, my undergrad supervisor said to me he really recommended that I look somewhere overseas. And the way he put it was, if you go to university in Australia, people will be willing to believe you know your stuff, you're a good scientist, but you really have to work hard to prove it. If you go to a big name university where there are lots of really top people working, people will assume that from the start. And so he recommended a top university in the US or the UK. And I really have found that to be the case. Since finishing at MIT, I followed not a conventional academic career at all, but nevertheless, there have been times that either I've got in touch with someone or someone's got in touch with me. And my background coming through MIT has really helped open doors that I wouldn't have had the time, given my Jesuit commitments, to force open if I had to.
And what was your thesis?
So my thesis or my research interest was in soft condensed matter theory. So the properties of materials that you study with statistical rather than quantum mechanics. And so my thesis had two halves. The first was looking on the degradation of lithium-ion batteries as they age and cycle. The second was looking at the behavior of fluids in the pores of materials, in particular, the shrinkage of cement paste and concrete as they dry.
How did you get from that to an interest in origami?
So, as so many times throughout, it wasn't based first on scientific interest, it was based on a personal connection, and it was a scientific interest that followed that. So from MIT, I'd been working in a chemical engineering group, and I thought I want to get into a physics department, even though I knew I was only going to be there for 1 year because I already had the Jesuits in mind. I wanted somewhere where physicists would know I'm doing physics. And so I went to University of Chicago, which I would say is probably the best place in the world to do soft condensed matter physics, and was working there in granular materials. I had a fellowship for that. But I happened to share an office with another postdoc whose interest was biological physics or biologically motivated physics. And he was interested in systems that can model biological systems, but in a much simpler way that we can understand. And so he, for some reasons about having large-scale geometrical constraints rather than purely local constraints, origami seemed to be a good system. So our plan was, okay, just put some generic origami patterns onto sheets. We're doing this in theory. We can make them and have occasionally made them in reality as well, but our work, actual research, is theory. Put a few generic patterns and see at what point the patterns start getting in each other's way. And instead of folding all of the distinct different shapes you want to make, you come up with some messy hybrid. But we realized we were stuck at step one, that put a generic pattern on, well, there's no technique in the literature for making a generic origami pattern. There are all sorts of patterns around, but they're usually constructed from some very nice symmetric or with some particular property of symmetry. And that was really sort of missing the point of what we were going for. And so we started, well, what are the criteria for making an origami pattern that is as generic as you can? And I really ended up taking that and running with it. And the biological motivation, I still mention from time to time if I'm in a biology crowd, but that hasn't been at the top of my mind for a very long time now.
Well, clearly in all of this, astronomy was not on the top of your mind.
That's right.
You've gone on, you did a couple of years as a novice, you studied philosophy,
Yep.
You've been working what they call Regency. Where did
Yeah.
you do that?
So I did that at a university college. So the University of Melbourne has something tending not all the way, but a little way towards the Oxbridge College system. In fact, it was a compromise to have a secular university, but to give the different denominations a college where if they wanted to, they could teach theology. Most of them haven't done much of that, but also as a residence for people of that particular faith who are studying at the university. And so the Catholic College was entrusted to the Jesuits just over 100 years ago. And so I was there in primarily a pastoral role. That was certainly the most important part of the role, just talking to students about what it's like to go through university, which is a real time of transition. And in particular, I happened to be there during COVID time. So it was good to be able to be a bit of a support to people who were, just dealing with university in a way they weren't expecting and certainly didn't really want, and just to help foster community. But during daytime hours where students were at class, which means in their room looking at a screen very much like the one I'm looking at the moment, I had some time to do a bit of research in that, a bit of chaplaincy at a hospital, a bit of study in biblical studies with a wonderful Australian Jesuit who's a scripture scholar. Yeah, and did make some research progress in that physics.
And so out of all of this, suddenly this summer,
Yes.
under obedience, you were forced, you were dragged against your will to this miserable place here in Rome, where suddenly you had to pretend to be a scientist again. And what's more, a kind of scientist that you're faking it a little bit.
Yes, yes.
Tell us what it was like when you first arrived here.
So I guess in two ways I was surprised. The first way was that the science was a bit more accessible than I was expecting. I was thinking that being an astronomy school, a lot of it might go over my head. And in a couple of the introductory ones that were looking at the astronomical context, I did find that sometimes that students would be here nodding along, all understanding everything, which I've learnt means maybe 5 or 6 of them were understanding everything and everyone else felt like they should be nodding along as well. But then we really quickly got into the computational part of it. And
I know, what was the school about?
It was a school about machine learning and data in astronomy. And although I've never been one on fancy computations, I'm more one on finding smart ways to do things so that you don't need some huge whiz-bang computer. I realized that actually in machine learning, that's the important skill as well. In fact, a lot of it is getting a smart enough way of doing your calculation that even a whiz-bang computer will be able to cope with the problem.
One of the things I remember learning when I was teaching in Kenya, and you had these students who were incredibly bright and phenomenally hardworking, and I'm talking graduate school, so these are quite advanced. But I'd give them a problem and they'd come back, sweat pouring down, and realized hard work is a sign that you haven't thought through the problem carefully.
Yes. Yes.
And then physics is basically based on laziness.
Absolutely. And I found that to be my skill. That I really found that niche. And when I was looking for jobs or looking for projects, I've made sure to narrow in on that there are some people who are much better programmers than me, but I'm a very good, terrible programmer. I can think of a way of simplifying physical models, getting to the real heart of it so that even my programming skills will be sufficient to solve the problem. And I've realized that that's actually a really important skill, and one that will get you more progress than thinking that every problem has to be solved just by making the computer bigger and the algorithm tweaking some details of data handling or where you're putting your data or your calculations being done. No, that can get you that last little step of the way, but getting the physics right, getting to understand, well, what are the important ways of expressing this question is the skill even in these areas. And so I found I was able to connect with all of that side of the academic content a bit more easily than I was expecting.
Well, what was the school like? I mean, you showed up at what time? What did you do? What was happening?
Yeah, so it was really quite an intense school. So there were, I guess, I'd say 4 really big parts to it. And the first one of those was lectures. And so that was the morning. So we had generally 2 75-minute lectures on machine learning techniques, going through from some of the more simple ones of classification algorithms and regression, even as far as linear regression, which I think will get you a long way, especially in either simpler problems or trying to get a visual and simple picture of what's really important there. Through a lot of the other ways of solving techniques, dimensional reduction, and then on to neural networks and deep learning in particular at the end of the school. And so that was the first 2.5 hours of the morning. Then the last hour, most of the time, was 3 students giving a talk about themselves, their country, and their science. And having all 3 of those, I felt really, they helped illuminate each other. That we saw not just some research results, but what had driven this student, what had given them the passion through their family, through their country, to be following a scientific career, and what had brought them to this particular area, whether it was, well, I'm from a small country, this is the only area where there's a lot of astronomy going on, or I followed this particular researcher, or maybe the world was my oyster, but I was particularly interested in this scientific question, or any of those.
Describe, just off the top of your head, first student in the school that pops in your head.
So the one that really came to my mind, because it really spoke to the Jesuit side of me, was a student who had come in from a video game perspective, and that was her pathway into astronomy. And there was a line on coming from her home country to the US and saying, realizing the importance of community in the workplace and the creative environment. And actually, one of my very good friends, who's a Jesuit, was a video game programmer before coming in. And he had noticed a bit of that in his vocational discernment to joining the Jesuits. And then she'd followed this video game path and realized that the kind of, I guess, way of storytelling in video games can open up such, it's a universe, it literally is the universe that's out there in astronomy, and that it is something fascinating, but it's something that needs to be brought to people, and that she had the skills and background to bring some of this to people, to be able to take them through a galaxy, our galaxy, or the universe, in a very, very visual way and with a bit of control like you have in a video game, that really does open this up in a way that we have available now in this technological world that wasn't there to the same extent in even 5 or 10 years ago.
Another one that comes to my mind is a fellow from a South American country that he grew up on an island. His dad was a fisherman, and he wound up doing well at university. And I remember asking him, here you are going to university, first in your family and all of that. How do they feel that you're studying something as useless as astronomy? And his answer was, they're so completely unfamiliar with academia, they don't know it's useless.
Yes.
Other people that you come to mind that maybe people you hung out with? Just to get a sense of the range of who is at the school.
Yeah, I think it was interesting to see the mix, that there was a very strong Latin American contingent there. And I think that the whole hemisphere dynamics is very interesting in astronomy, because we all know how sort of the geopolitics plays out, that the wealth has been very unevenly concentrated in the world. People are very unevenly spread. And sometimes in science, we think, oh, well, that's sort of off in some politics space. But in astronomy, it's very real because it affects what we can do. In fact, the project that I worked on was looking for quasars in the Southern Hemisphere, because we need to open up that place for exploring our universe in that direction.
We'll talk about projects, because that was another element of the 4 elements. So
that's right. So that was what we often spent our afternoons on, was some research projects. And so we split up into 7 groups of 3 or 4, and had just an introduction to, well, what are the research skills that are used in a particular area. And so my particular one, with some students from China, Denmark, and Slovenia, was looking at quasars in the Southern Hemisphere, and in particular, looking at more distant quasars at redshift beyond 2.5. And so, although the perhaps focus of that, or where we think the particular physics is going on, or techniques, machine learning techniques, was in the machine learning to classify, well, what's a star? Because if we have a huge catalog, almost everything is a star. And so we need to be able to identify quasars in a very imbalanced data set. But coming up with that data set takes more of the time. It's not necessarily a scientific process, but just a process of accessing databases, getting the data in the right form, matching up stars from one database with another, looking at the uncertainty in different position measurements, making sure you have enough data at any points, which ones you can throw away. That's where all of the real time is spent. And then you have your data set, and there are some very good machine learning algorithms that you can pull up and run through very quickly to get a sort of first go at it before you start to be.
Of all of these dots, these 12 dots are the quasars.
That's right.
And everything else you can forget.
Yes, it's coming up with all the pattern of dots that takes the time, but the identifying which dot might be a quasar, quicker than I expected.
Well, that's 3 things. What was the 4th thing that you did at the school?
We're in Italy. We're just outside Rome. We're in a place that people want to see and people love to see. And it really is a way of bringing the group together as as a team. And so we went off to Florence on the first weekend and went through the observatory there and the Galileo Museum, and then did a bit of exploring of our own, and the Uffizi I went to, for instance, and just wandering around some of the views. We went off to Subiaco, one of the earliest monasteries of St. Benedict, and then also the cave where he spent time working out how God was calling him. We went off to a very extensive archaeological site at Ostia. And then we also went to the Vatican Museum. We were due to meet the Pope. Unfortunately, he was in hospital at the time, so we weren't able to. But people really love to see that this observatory is a wonderful place of science, and it's integrated into this world of faith and culture that you don't find in the same way anywhere else in the world. Italy is an amazing place, and Rome in particular.
So what struck you when you were in the Vatican Museum? What was it that you said, oh my gosh, I didn't realize I could see that?
So for me, it was the School of Athens. That was the highlight. And it was in fact on the badges at the school. And at the end of the school, as a thank you card for people, the students made a photo where they reenacted all in the various positions.
So all the students who were posed the way that Raphael's famous School of Athens
yes,
painting.
Yes, with Plato pointing up to the ideal world and Aristotle out to the world of here and now, and that the philosophy and knowledge is contained in there.
And instead of reading a book, one guy was lounging and looking at his laptop. Is that right?
That's right, and that's certainly accurate updating, shall we say, of the piece. So that was the particular artwork that I love the most, because I've seen that, and I think it really does speak to the history of knowledge. Getting into philosophy, at first, I wasn't such a fan of Greek philosophy because I thought most of their answers are wrong. As I studied a bit more, I realized the key is their questions are right. Okay, they might not know the details of the questions, but the way of setting about starting to ask them. And in particular, that you need to consider all of the world together. To ask what is a good person and to ask what is a good state, you shouldn't be asking them individually, you should be asking them together. And to know how we know, to understand what is, and to understand what is right morally, we need to let these questions talk to each other. And I think that's something that we really need to be conscious of as much today as 2,500 years ago. So
we did feed these people.
Yes.
Can you talk a little bit about the food, not only what we fed you, but then what you guys did in the evenings?
Oh, yes. So at lunchtime, we were served, I'd say, a traditional Italian meal, pasta, occasionally risotto, as a first course, and then a second course of a meat and some vegetables. And students really enjoyed that. There's something about the freshness of Italian food that is a bit different from other places. That's like the apricots I mentioned earlier. You realize that even the food you buy, it's like food that you get from your farm by going and picking it off the tree or digging it up yourself. And that's something that's really, really a joy. And it just makes it a time for bringing people together, that it makes you happy. There's a little bit of wine around, and people like the time. People like each other's company, and they want to build that community.
Who were some of the guests who came?
So we had as guests some ambassadors from the various countries, ambassadors to the Holy See from the countries who had students here. And so students were really excited when their ambassador came, because it's such an international school. 24 students from, I think, about 20 different countries. And we rejoiced in that. It was great to hear about other countries. That was part of the reason, that was part of the talks that the students gave. And so when their ambassador was coming, students loved to have that little touch of home and to talk in their own language for a little bit. Also, I think some people liked putting on their nicer clothes they'd brought to meet the Pope. Well, put them on to meet the ambassador instead. We also had I'm not certain of the terminology, but the governor and secretary general or something equivalent of the Vatican City State come for the the final lunch to sort of bring things to a close.
So
and
you didn't get to meet the Pope, but you did get to meet two cardinals.
that's right, two cardinals, and then a sister who's the Secretary General, and they just come across as holy people. And as a person in the church, we can sometimes get disheartened that the church does not always live up to the vision that we have. I'm sure there are people around the Vatican who are a bit career-oriented and in it for themselves sometimes. But we met people who were not like that, who clearly have a faith, they have a humility, and they have a desire to get to know people. They come with the belief that the person they meet is doing some valuable work to build up God's kingdom, and that they want to play their part in supporting that through the particular positions in the Vatican administration they have.
So among the other meals that you had a couple where the evenings where you guys did the cooking.
That's right. The Fridays in particular, we had a bit of a celebration. The second Friday in particular was quite an event. In fact, in Denmark, there's a tradition that at big parties, particularly at graduation, but other parties as well, you begin with a formal dance, particularly the lanciers, which I think is a French dance, but now most popular in Denmark. And so our Danish student taught it all to us, complete with counting in Danish. And so that was a way we opened the party to open up the party for the marking the halfway point of the school. And then the students all cooked Mexican food for that second week. And for the third week, actually, they roped in one of the lecturers to lead the cooking, and he cooked us some Croatian food with some help from the students. And we had some great Danish desserts the first time and Canadian maple syrup. I think that was the highlight. The Danish ones were well up there too.
Right,
but
right. She's holding this and she says, in our country, we call these Danish. And I'm going, yeah, that's what we call them too.
Yes. But I think you can't go past a maple syrup flavored dessert.
Had you had real maple syrup before?
Oh, yes. I've been to Canada. I've been to New
All
England.
right.
Well, I lived in New England. I live in New England at the moment. So yes,
Of course, right.
I'm familiar with maple syrup.
Yes.
It is a treat.
Yeah. Looking back, when you go back to, where are you going back to? What's on your schedule when you head back to?
Well, eventually I'll get back to Boston for my second year of theology studies, but I'll take the scenic route. I'll go through Slovenia and Austria and Portugal and Spain on my way.
Are you going to be looking up any of the students?
I don't think I'll be able to catch up with any of the students, but I did get a couple of recommendations of good tourist sites to go to.
Okay.
Yeah.
When you get back to Boston, what are you going to be telling the other Jesuits in theology? What you did in your summer vacation?
Well, I'll be telling them that I worked harder than I was expecting. I thought it would be here sort of like I was doing when I was at the college. Oh, a bit of pastoral ministry, talking to students. Oh, how's things going for you? They had me working as hard as any of the students on the really doing science, which was great, but it was sort of, this was more work that I was getting in for. It's nice to have a holiday week now, just visiting some sites of Rome. But a particular thing that I'll mention is how important the Jesuit community and the Jesuit nature of this has been, because it's something that I've been talking about when we gather as a cohort, those students who have been in their first year of theology. We gather a couple of times per semester to talk about, what's really important. And one thing for me is I love science. And the more I've been going on as a Jesuit, the more I've been convinced that it is a background that most Jesuits have. It is something that I want to make use of and that I really believe the church needs me to make use of. But how does it tie in with being a member of a religious order, a worldwide religious order, with our particular spirituality, with our particular institutions? And I come here and I see the Vatican Observatory and I realize this is an important place. This is a kind of institution that Ignatius was looking for. It achieves excellence in its field of astronomy, but it also does something that other excellent observatories don't do. It has this way of looking outwards into the world as well as into the heavens, that a lot of the people, the alumni who gave guest lectures or who are faculty here, said this will be one of the most important experiences and certainly the most important summer school of your life because it has that focus on people. It recognizes that it's great to learn science. It's important to learn science. We spent most of our time here learning science, but we were also here to build connections. And that's one of the deliberate goals of the school. And that's who we are as Jesuits. Yes, we're here to do science, but we're here to do science because we have a mission from Jesus to be of service to people in the world and to witness to Christ in that way. And we do it as a community of brothers in Christ who have this shared vocation. And to see the combinations of those vocations of the Jesuits here who are wonderful scientists and passionate about scientists, but also belong together in this community, this vowed religious community, living the common life, the common spirituality, and seeking to deliberately foster places of service, of connection, of reflection on what's important in life. This is a place that is really living out the Jesuit vocation. And I hope that other Jesuits find their own niche that combines their own backgrounds in the same kind of way.
So I'll end with this. You described when you were young, being part of this international Olympiad, that you discovered a community of people that you said, oh, I can be one of them.
Yes.
Did you have that experience when you came to the school?
Absolutely. I did notice that, okay, I'm not one of these students anymore. I was one of them 10 or 15 years ago. So I noticed, yeah, I'm looking on half in, half out. That's how I felt socially. Academically, I was very much integrated in the stream of it. But socially, there were times I thought, yes, it'll be great to be involved, to be part of this community, to be contributing. There are other times I thought, it's time to step back, let the students let their hair down. This ancient mid-30-year-old doesn't need to be staying up as late as them and so forth. But one thing I really noticed, I went to a 4-week summer school like this one that was in the US. It was primarily from people studying in the US. Quite a few countries of origin, but almost all studying in the US. People were brought together there because they were really good at physics. I came here, people are brought together here because they really love astronomy. Yes, most of them are absolutely top-notch. Some of them are on their way to being top-notch. But they all love it. And that's what makes this, the back and forth in the lectures particularly so vibrant, is that they breathe this, that there's something about astronomy that, I'm going to be honest, I love physics in this way. I don't love astronomy in this way yet. I look at those stars, yeah, they're pretty. They look at those stars and they have this passion and drive for it that I have this passion for understanding the world as a physicist. It's a close cousin, but it's not quite the same. But I see, yeah, this passion, this fire that motivates people that you can't not do it. It's like Jeremiah as a prophet, I think. If you try to bottle up this love of science, you can't. That's what I saw at this school. That's what I felt inside me. And that's why I want to live this life as a Jesuit, as a scientist as well.
Thank you so much. Thanks for the passion and the enthusiasm you brought to this. And thanks to everybody here. We'll see you the next full moon.
Thank you.
That's a wrap for this podcast. The audio editors for this podcast were Brother Guy Consolmagno and myself, Bob Trembley. You can listen to our other podcasts and read our posts on the web at VaticanObservatory.org. If you'd like to attend our full moon meetups live, join our Sacred Space Astronomy community, also at VaticanObservatory.org. Clear skies, everyone!